Okay, so ecological populations, as I said, they do not remain the same and they change with time, okay? So these changes are due to some maybe internal factors or external factors. Okay, these changes are of two types: population fluctuation, and population cycle. Okay, this one and that one. All right. So in the first one, population fluctuation, population density tends to fluctuate irregularly above and below some steady state level. Okay, like I said, with the carrying capacity, if this is the carrying capacity here, this one carrying capacity, the straight line, it will fluctuate beyond, sometimes better than the steady state, sometimes worse than it. Okay, these are seen by sudden increase in population in short span of time, which is followed by equally quick decrease in population size. All right, just like that, when they fluctuate along the carrying capacity. So they are caused by random seasonal or annual changes in availability of resources, or sometimes extrinsic factors, that is temperature, rainfall, etc. Okay, an example here: more birds during early summer due to their hatching period, more insects during summer months, and more weeds in the rainy season. Okay, later on, the birds, many of them will die off. The moths, many of them will be eaten by other animals, and so on and so forth. Okay, then let's look at the population cycle. These are regular changes in the population size. Okay, in these, the population size is nearly constant over a long period of time. Okay, so this one, it takes place in a long time. Fluctuation is in a short time, either in the season or in the year. Okay, but here cycle, it takes place in a long time. So they are caused by seasonal changes in the environment. Example, a population cycle of around 3 to 4 years of the lemmings of the tundra. Okay, these are some sort of animals that we find in the tundras. So these lemmings, they are like mice, like mice, like rodents. Okay, they are found in the Arctic region in Norway and Canada. And these rodents, these lemmings, they increase in the number for a period of about 3 years until it reaches a peak beyond the carrying capacity of that area. So suddenly in 3 to 4 years, there will be so much that that area cannot support. They have eaten all the food, they've occupied all the space, and then in the winter months, the lemmings will migrate in large numbers to the sea and swim till they drown or they die due to exhaustion. Okay, then only those surviving lemmings, okay, who reach back to the same place when the winter ends, they will repeat the process. Okay. Then most ecologists, they use some parameters to draw the conclusion about how the population, they have evolved. Okay, so there was some theory called as R and K selection, given by MacArthur and Wilson. Okay, these R selected population, they have high intrinsic rate of growth. Okay, R big. Okay, R, they tend to boom, means they quickly reproduce when the environmental conditions are favorable and best. Okay, so they show very big fluctuations. Okay, suddenly the population will decrease or suddenly it will increase depending on the environment. Then the K selected, these are like humans. Okay, they are relatively constant density at or near the carrying capacity. Okay, so the symbol for carrying capacity was K. No, so you remember K selected is where they live near the carrying capacity. So you can see the differences between R selected and K selected species. In R selected, they are unpredictable. Okay, they will boom. K selected, we can predict. Okay, like I can see in 10 years, the population of India will be so and so, because we know how much we can reproduce. Then the survivorship curve is concave in R selected and convex in K selected. They can give birth very high, and K, they will give birth low. Density is below carrying capacity, density is constant, okay? Then the R selected will be like rodents, they have small body size, and whereas K selected, they'll be like us, okay, large body size. Then they can disperse very quickly, like insects and all. And humans, K selected, we cannot disperse much, okay? And so on and so forth. So with this, I have completed this chapter, but there is one more that I have to show you, that is the ecological pyramids, okay? So with this, at least I have completed population ecology, the complete chapter, okay? Everything is done in community, in population, everything. But I have seen that that soil factor is there, no, in my name. So that one also I will show you. I have found some books, but then I'm still not satisfied, so I'll keep on searching for a better note, okay? That soil profile, soil factor, soil profile. So that one is left with you and me. And then physiology, if possible, I prefer we do it face to face, so that you don't panic. Like, you understand that it's not as tough as it seems like. So here online, I will if I get a good note, maybe I will just send you that soil factors. I will explain a little bit. It's not that much, I think, not that tough. Obviously, it's a soil factor only. No, we just have to by heart it. So with this, I will end this population here. Then I will do the ecological pyramids.